This video explains how to connect an ESP8266 to an OLED display with the Wi-Fi Manager. It uses the network time protocol to get time and then display that, and the ticker library. Here's the Wemos boards. There's the main board, the ESP8266, otherwise known as the D1 Mini. There's the back, nothing unusual about that. There's the OLED shield. It's a 64-bit by 64 pixel by 48 pixel display. It's set to address 3C. Stack the display onto the board, and there it is, ready to be used. Power up the display, and immediately it will show all zeros because it can't make a network connection. Syncing, it shows the Unix epoch time. So what's happening now is the Wi-Fi Manager, that's part of the source code there, is trying to make a network connection. And so the board is, note there in the code, you have to uncomment Wi-Fi Manager.reset settings. So what happens is the board starts up in access mode, and it's called, the access point is called ESP8266_AP, and there it is. So I'm going to connect to that on my Wi-Fi network, connect to that router or access point. There's the software that's come from the ESP8266. Now it's suggesting that we configure the Wi-Fi. There's the available networks. I'm going to choose the one at the bottom there. Click on that one, and it'll automatically complete the SSID, and then I'll enter the network password. Scanned computer no longer activated because I've lost the main network connection. So we're just connected to the ESP8266 at the moment, under the control of the Wi-Fi Manager. So all this text here, this HTML, is coming from the Wi-Fi Manager. There it is, connected. You can see the date and the time. Watch the seconds, and they're synchronized with that radio controlled clock. And there it is, operating as expected. So let's do a quick code walkthrough. And the first thing we need to look at is start the time client, initialize the display. This little OLED display uses the Adafruit 1306 library. Print some synchronizing text there. You saw that come up on the display. And actually update the display. The ticker, this is the ticker routine that every 986 milliseconds will call this display routine here. So independently of the main loop, approximately every second display time will be called. Just initialize 60 seconds so that first test to update the time client is triggered. Wait a second and just keep going around that loop. You can do anything like in that loop because the interrupt, the ticker, will keep on displaying time every 1 second. And the first thing inside the display loop is to get the Unix epoch time from the NTPClient, which is a long Unix number. Generate the hours, minutes and seconds from those from that 32-bit number. Get the current year, month, and that's a modulus 12 to get the current month from the total number of months since the Unix epoch's time. Get the current day, since epoch time, and then the day of the week, which is 0 is Sunday. The next part of the routine is to get the actual day, what's called day. Current day is in the month, so it's the 13th of September today. The result is 13. From there, clear the display, set text size to 1. There's only 2 colours available with this display, white and black. Reset the cursor back to the home position, and because I like to center the day of the week, Tuesday in this case, I just quickly print the spaces commensurate with getting it central, print the day of the week, Tuesday. Then the next part of the routine is to print the day, month and year. Increase the text size for the time, move the cursor down, print some leading zeros and for both hours and minutes with a colon in between. The only way you can erase these displays is to fill a rectangle with black, so where the last seconds display was, do that, set text size to 1, increment the second count and then print seconds again with leading zeros. Finally update the display, and it will then go back to where it was called, and it will go back into that loop, having interrupted the loop, and that loop will keep repeating until the seconds count, which is updated by display time, is greater than 59, and then it'll update the time, and then the whole process will start again. So that's a quick code walkthrough. So there's the display ticking away nicely, and that concludes this video on how to set up an ESP8266 to display accurate time.